Hi, and welcome back to Stats Online. Today's topic is confidence intervals around sample proportions. In previous lessons, we talked about constructing and interpreting confidence intervals around sample means. And to motivate this, let's look at this Gallup polling result that says, in particular here, 45% of Americans approve of President Obama's job performance. My first question that I pose is 0.45 as a proportion instead of a percentage the population proportion of Americans that approve of the president's performance? And the answer to that question, hopefully it's obvious, is that it is not, right? This whenever a polling agency like Gallup produces a report like this, it's based on a sample of data. And you may be able to see that the sample of data here is 1,500 national adults. Okay, so it very much is a sample statistic, and in particular, it's a sample proportion. Knowing that this is just a single statistic drawn from a larger population, Gallup wants to know how confident they are that their sample statistic is close to the actual and, of course, unknown population parameter, right? It's unknown, and hence the reason for inferential statistics in the first place. They'd like to know what this percentage approval is or disapproval, but of course they can't get at it from every adult American at one point in time. So they draw a sample. And so to answer this question about how close it is to the unknown parameter value, they construct an interval, a confidence interval around their sample statistic, and say something about how confident they are that this interval contains the true and, of course, unknown population parameter. So we'll go back at the end of this lesson and try to recreate their interval. I'm pulling this from the bottom of the image here and separating it on its own slides. Okay, Gallup tracks the daily percentage of Americans who approve or disapprove of Obama in terms of his job performance, based in telephone interviews, with approximately 1,500 national adults. And they report a margin of error, plus or minus 3 percentage points. And the margin of error is exactly what we need to calculate to construct a confidence interval. In fact, the margin of error is exactly what you add to your sample statistic to get the upper limit and subtract for your sample statistic to get the lower limit. Right? So what Gallup is actually saying at the end of the day is that they're 95% confident that the true population proportion of Americans that approve of Obama is plus or minus 3 percentage points. So that would make it between 42% and 48%. So let's talk about confidence intervals for proportions. The starting point is that there's an unknown population proportion, and that's pi, and we need to estimate pi. We don't know it. Our best estimate is p bar, sample proportion, just like x bar is our best estimate of mu, the population mean. When the sampling distribution for p bar is normally distributed, and in the next slide we'll remind you of what those conditions are to approximate a binomial distribution as normal, the mean of that distribution is equal to the population parameter. That means it's an unbiased estimator of the unknown parameter value. And the standard error follows the following, is containing the following formula. We'll notice that the standard error of the sampling distribution contains this population value pi, which of course we're not going to know. And so on the next slide we'll discuss how we're going to deal with that. So again, we don't know pi. Here are the two conditions that, if satisfied, we can approximate safely. We can approximate the binomial distribution, which is the distribution of data that comes from binary outcomes, like do you approve or disapprove. And if both of these are satisfied, then that distribution is normal. However, we need pi. What we're going to do is use the information that we have, the best information that we have, which is our sample proportion. All right. So actually, this you wouldn't find until ex post if your sample that you took, given your sample statistic of pi, was sufficient to reach this constraint of 10. But it doesn't take much, right? If p bar is 0.5, we know that as long as n is 20 or more, that's going to work. And so we're talking about not huge samples to satisfy these conditions as long as that sample proportion is not known to be or thought to be extremely close to 1 or extremely close to 0. So we're going to use sample data to check the two-part test for normality. And we're going to use this sample data, meaning p bar, the statistic that comes from that sample data, to estimate our standard error, which I've circled here. And so we're talking about p bar. So this is the confidence interval formula here. P bar, the sample statistic, plus or minus, plus and minus, plus for the upper limit, minus for the lower limit. My critical z-value, which depends on my level of confidence, alpha. No, alpha is the level of significance, but that depends on the level of confidence. And it's circled here, of course, is the standard error. So p bar plus and minus the margin of error, right, which is the product of my critical value and standard error, will give us all we need for the confidence interval. So let's get some practice with this. 24% of a sample of 1,004 national adults told Gallup that they smoke cigarettes. So let's estimate the standard error from this data set. Okay, so to estimate the standard error, we're looking at the square root. Remember, p bar times 1 minus p bar over n, which is the square root 0.24 times 0.76 over the sample size. And that is 0.0135. So B is the answer there. Now, to determine the margin of error for the 90% confidence interval, which is E, the other component we need is the critical value times standard error, which we already calculated. And the Z score for the 90% confidence interval is 1.645. And so that product is going to lead us to B, 0.221. So the margin of error is either 0.221 as a proportion or 2.21%. So finally, to determine the upper and lower limits of the 90% confidence interval, right, we're talking about a lower bound that is going to be 24% minus 2.21, 24% plus 2.21, and so 21.79%, 26. All right, so we're 90% confident, or Gallup's 90% confident, that the true proportion or percentage, however we want to phrase it, of Americans that smoke, American adults, is between 21.79% and 26.21%. So going back to the beginning slide, according to the recent Gallup poll, 45% of Americans approve of the president's job performance. And these results are based on telephone interviews of 1,500 adults. Let's calculate the margin of error for the 95% confidence interval and compare it to what Gallup reports. Well, the margin of error for the 95% is going to be 1.96 times the standard error, which by our metric is this. And we're going to get 2.4%. Where Gallup reports 3%, there could be a number of reasons. Theirs is a more conservative estimate, means it's bigger. That means that without reporting their level of confidence, they may be looking at, so this is the 95%, they could be extending that to the 99%. We do know that Gallup, regardless of what P bar is, will always plug in 0.5 for its sample proportion, because that makes this numerator as large as it could be, right? 0.5 would make that as large as it could be. Another reason that Gallup could be slightly more conservative is that they've got 2.4%, and the most conservative thing you could do is to round that. Right, and in that case, it would be up.